Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. We're told that theta is small, and we're actually told that we are going to use the small angle approximations. So if we just list them out, we know that cos theta is roughly the same as 1 minus theta squared over 2. We know that tan theta is roughly the same as theta, and we know that sine theta is going to be roughly the same as theta. So looking at the question, we've first of all got a cos 2 theta. So for this one, instead of cos theta, it's cos 2 theta. So that's just going to be roughly the same as 1 minus 2 theta squared over 2. Now we can actually just expand this a little bit. So that's going to be 1 minus, and 2 squared is going to be 4 theta squared over 2, which is roughly going to be the same as, we're just going to cancel the 4 and the 2, so it would just be 2 theta squared. Next we've got tan 2 theta. So instead of tan theta, we've got tan 2 theta, so that's going to be roughly the same as just 2 theta. And finally we've got a sine 2 theta, which is also going to be roughly the same as just 2 theta. So the next thing we're going to do is just write this out, but instead of the cos 2 theta, we're going to write 1 minus 2 theta squared. Instead of the tan 2 theta, it's just 2 theta. Instead of the sine theta, it's just sine 2 theta, it's just going to be the 2 theta. So it's going to be 1 minus, and then this is going to be brackets 1 minus 2 theta squared. And then all of that is going to be over, instead of tan 2 theta, it's just going to be that 2 theta, times, and instead of sine 2 theta, it's just going to be 2 theta. I'm going to expand the bracket at the top. So that's going to be 1 take away 1, which is just 0, and minus times a minus is a positive, so it's just going to be 2 theta squared. And that's going to be over 2 times 2, which is 4, theta times theta, which is theta squared. Then we can cancel the theta squared, and we can also divide top and bottom by 2, so it's just going to be 1 over 2, or 1/2. We're asked to differentiate, so I'm just going to go through each of the terms. So we're going to find dy by dx. I'm going to start with the 7x to the power of 4. So we are going to multiply the power by the coefficient, so 7 times 4, which is 28. And then we're going to subtract 1 from the power, so that will be 3. Next we're going to do the minus 28x cubed, so we're going to do minus 28 times 3, which is minus 84. And subtract 1 from the power, so that will be x squared. Now the minus 2 at the end will just disappear, it will just turn to 0. So that's our answer. For part B, we need to find the second derivative, and to do that we just need to differentiate our answer to part A. So just show that I'm finding the second derivative. And we're going to start with the 28x to the power of 3. So we're going to times the 28 by the 3 to make 84. And then again subtract 1 from the power, so 3 becomes 2. Then we're going to do minus 84 times 2, which is going to be minus 168. And we're going to subtract 1 from the power, so 2 take away 1 is 1, so we can just leave that as x. To verify that C has a stationary point at x equals 3, we just need to substitute in 3 into our differential equation from part A, which is the 28x cubed minus 84x squared. And if it equals 0, it must be a stationary point. So we're going to start off by just substituting in. So we've got the dy by dx, and it is going to be 28 times x, which we're saying is 3, cubed minus 84 times x, which was 3, squared. And when you type that into a calculator, you get 0. So therefore, stationary point is at x equals 3. For part D, we're asked to determine the nature of the stationary point, and to do so we're going to use the second derivative from part B, and we're going to substitute in x equals 3 and see what type of value we have. So we're going to have the second derivative, and we're going to substitute in that x equals 3, so it's going to be 84 times 3 squared minus 168 times 3. Now, doing that on a calculator, that gives an answer of 252. Now, 252 is positive, it is greater than 0. So what's going to happen with our graph is it's going to be slowly increasing as you go to the right. And the way, if you have a look, it's slowly increasing. This is quite a sharp drop, but then here is a bit of a less drop. And then here is an even less drop, so you can see that it's increasing. So it's going to show that it is a minimum point. So we're going to say, therefore, the stationary point is a minimum. In this question, we're given the arc length of this sector, we're given the angle of the sector, and we're effectively asked to find the radius of the sector. So the equation or the formula that we know that links all of those things will be arc length is equal to the radius times theta. And let's just get our lines in. Now the arc length will be that 8. The radius we're trying to find, and we see that the angle is 0.4. So both sides we're going to divide by that 0.4. And 8 divided by 0.4 will be 20. So the radius will be 20, and therefore OD will be 20 centimeters. We're asked to find the area of the shaded sector AOB, and AOB is going to be this part here, the bit that's shaded. So I'm going to start just by writing the formula for the area of a sector. So area of a sector is half r squared theta, only when working in radians. We'll get our lines down ready. Notice we need to find two things. We need to find r, and we need to find the angle, so radius and the angle. So let's find those things now. The radius is going to be this part here, and we're given the fact that the total is 23. We've worked out this part is 20, so it's going to be, so what is it, AO. So AO is going to be 23 minus 20, which is going to be 3. So we know that's going to be 3 centimeters. And we need to find this angle here. Well, we're given that this angle is 0.4, and half a turn, so normally it would be 180 degrees, obviously in degrees. Half a turn is pi in radians, so it's going to be pi minus the bit we know. So what angle is it? AOB. So angle AOB is pi minus 0.4. So we plug these into our formula. So it's going to be half times the radius, which we've said is 3, squared times this pi minus 0.4. Put that into the calculator, and to 3 significant figures it will be 12.3 and it'll be centimetres squared because it's an area. In this question, we're asked to find the inverse function with an input of 15 of this function here. And it's basically a fancy way of saying that the output of this function will be 15 and find out what x is. So all we need to do is put the output of this function equal to 15. So it's going to be 11x minus 7 over x minus 2. And let's put our lines in. Okay, so the first thing I want to do is get rid of the fraction, so we're going to multiply by x minus 2 both sides, and just make sure you put them in brackets, because that will help us to figure out what we do on the left hand side, because it's going to be 15 brackets x minus 2, and then we've got just the numerator we have to deal with on the right hand side. Let's expand those brackets, so 15x minus 30. Now we've got x on both sides, and the rule is to get rid of the smaller amount of x. So here the 11x is the smaller amount, so we're going to take away 11x from both sides. So 15x minus 11x will be 4x. Minus 30 is equal to just minus 7. And let's get the numbers on the same side, so we're going to add 30 to both sides. So minus 7 plus 30 is 23. Divide by 4 both sides. So x is going to be 23 over 4. And that'll be our answer. In this question, we're asked to find f of x. So we're going to feed in the function into the function. So every time we see x, which is here and here, we're going to substitute in the actual function. Now we've got to make sure that we leave lots of space, because it's quite easy to get confused and muddled up with this. Let's start just by doing the fraction. So we've got 11x, so it'd be 11 times the function, which is 11x minus 7 over x minus 2, minus 7 over x, which is the function again, minus 2. So we're going to get rid of the brackets, so we're going to multiply them out. So it'll be 121x minus 77 over x minus 2, take away 7, and we just get rid of the brackets here. So whenever we have a fraction and a number and we're subtracting or adding, we need to make them both fractions, and we need to make the denominators the same. So here we have x minus 2, so we need that 7 to be over x minus 2. And we do that by multiplying the 7 by x minus 2 over x minus 2. So we're not doing anything with the first one, so we'll just leave that as 121x minus 77 over x minus 2. And we're going to times that 7 by x minus 2 over x minus 2. Then we're going to do the same with the bottom. And we're going to times that 2 by x minus 2 over x minus 2. Let's expand the brackets. So first term will be the same, not doing anything with that first term. So 7 times x, 7x, 7 times 2 is going to be 14. And then x minus 2 at the bottom. And then we've got 2 times x, which is 2x, 2 times 2, which is going to be 4. Okay, now that the bottoms are the same, we can just subtract the tops. Just make sure we leave ourselves lots of space. So it's going to be 121x minus 77. Now we're going to subtract the whole of that, so we need to make sure we put it into brackets. And all of that is going to be over x minus 2. And do the same with the bottom, so 11x minus 7, take away the whole of 2x minus 4. All of that is going to be over x minus 2. So what we can do now is we can times top and bottom by x minus 2. So we're effectively timesing the fraction by 1, but we're just going to represent 1 by x minus 2 over x minus 2. And what that'll do is it will get rid of the fractions on the numerator and the denominator, which will be nice. So we're just left with 121x minus 77, and we might as well multiply out the brackets here. So minus times 7x is minus 7x, minus times minus 14 is going to be plus 14, and same at the bottom, 11x minus 7, minus times 2x is minus 2x, minus times minus 4 is going to be plus 4. And now we just need to collect the like terms. So 121x minus 7x is going to be 114x. Minus 77 plus 14 is going to be minus 63. 11x minus 2x is going to be 9x. And minus 7 plus 4 is going to be minus 3. Now looking at the question, we're asked to find A and B. So A will be the 114. And B will be negative 63. We're told that the fastest speed of the car is modelled by an arithmetic sequence, and that's important. It means that we can use this formula, that the nth term is the first term plus the number we're on minus 1 times the difference. And because we're asked to find the speed of the third gear, we need to find out what that common difference is. Well, we know what A is because it's given to us in the question. It says that the first gear is 34 kilometers per hour. And we know at the sixth gear what the speed is. So we know at the sixth gear, the speed is 113. And so we're just going to substitute everything we know in. So it'd be 34 plus n for that would be 6 minus 1d. And let's just get our lines in and solve. So yes, first of all, just expand the brackets. Well, it's just going to be 5d. And take away 34 from both sides. So 113 take away 34 is 79. Divide by 5 both sides. And so that will be 15.8. So we know that D is 15.8. So we're going to use the formula again, but this time to find out what the third term is. So the third term will be A, which is 34, plus 3 minus 1 times that common difference, 15.8. Plug that into a calculator and you get 65.6. So our answer is 65.6 kilometers per hour. Part B seems like it's the same question as part A, but this time it says that we're going to model it as a geometric sequence, which means instead of adding something each time, we're multiplying something. And the formula for that is un, so the nth term is going to be the first number times the common ratio to the power of n minus 1. Now we've got enough information to find out what r is, because we know, just like we did with the previous question, that the fifth gear will be the sixth gear will be 113. So we look back, sixth gear is 113. And so it's going to be 113 equals A, which is our first gear, which is 34, r to the power of 5, because it's 4 minus 1. And so we get our lines in again. And we're going to start by dividing by 34. So that would be 113 over 34. And this time we're going to fifth root both sides. Find the fifth root of both sides, and we get 1.271 blah 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 on the calculator. And we're going to just feed that back into the formula, because this time we know what that common ratio is. So to find the, we actually know which one it is. We're finding the fifth gear. So it's going to be 34 times that number we've still got on the calculator, and make sure you still keep it on the calculator to make sure that we keep the precision, to the power of n minus 1, which would be 4 this time because it's the fifth gear. 5 take away 1. Put that into the calculator and you get 88.870 blah blah blah, which to three significant figures, which is what it asks us for, is 88.9, and that would be kilometers per hour. Whenever we see these types of questions to ask us to rearrange an equation into a certain form which looks like this, the first thing that should be going into your head is that we're going to be completing the square. So to do that, first of all, we're going to have to deal with that horrible 2 there. We don't want any coefficients of the x squared. So I'm going to just start by getting rid of that, getting that out. So we're going to look at the first two terms and we're just going to divide them by 2. And so we've got 2 brackets x squared plus 2x plus 10. And that makes things a lot easier to get rid of that horrible coefficient of the x squared. Okay, so to complete the square, what we're going to do is have a look at the coefficient of the x, which is 2. And we're going to think, right, what's half of that? And we're going to put that into the squared bracket. So it's going to be x plus 1 squared. Now, when we expand x plus 1, which we'll do quickly up here, when we expand x plus 1 squared, we're going to have x squared, perfect. We're going to have 1x plus 1x, which is 2x, perfect. But then we're going to have this horrible plus 1 at the end. We don't want that, that's horrible. So what we need to do is get rid of it, and the way of getting rid of it is we're going to subtract 1. And then we're going to plus the 10, which was there before. Okay, so to neaten this up, we're going to expand the square brackets we've got. So we've got 2 brackets x plus 1 squared. We're going to do 2 times the minus 1, which is minus 2, and then plus 10. And that will just leave us with the first bit, and then minus 2 plus 10, which would be plus 8. For part B, we kind of need to understand our answer to part A. So for our answer to part A, each of the parts of this bit here means something when it comes to the graph. So talking about the minimum or maximum point of the quadratic, well, the quadratic is going to be positive, so we know that it's going to be a U shape. So we're talking about the minimum point. The minimum point will always be at 0, 0 for a normal quadratic, where it's just y equals x squared. But when you have it in this form here, you can see exactly what's going to happen to that minimum. That plus 1 inside the bracket will mean it will go to the left 1. So the minimum, instead of being at 0, 0, will be at minus 1, 0. The 8 here, the plus 8, means it's going to go up 8. So our minimum now is here. And so the graph is going to look like this. The other point we need to find out is the y-intercept. And to do that, we're just going to put in 0 into the equation. So to find the y-intercept, we're going to do 2 brackets 0 plus 1 squared plus 8. So that's just going to be 2 plus 8, because it would be 1 squared, 1's 2 times 1, 2, and so that would be 10. So the y-intercept is 10. So we're going to have to sketch our quadratic. Try our best. And we want a U shape with a minimum, and we just label on where these coordinates are going to be. So that's going to be left 1, up 8, looking at our answer to part A, and we know that the y-intercept is going to be at 10. So we notice that gx doesn't look it isn't the same as fx, but it does look similar. So with f of x, we've got the 2x squared, but with g of x, we've kind of got the 2, but this time it's x minus 2 squared. So the first thing I'm going to do with this is I'm going to, instead of f of x, I'm going to just do x minus 2 to our f of x. So f of x minus 2. So every time we see an x, we're just going to replace it with x minus 2. So it's 2 brackets. Instead of x squared, it would be x minus 2 squared. And then instead of plus 4x, we're going to have plus 4x minus 2. And then we've got plus 10. Well, that will stay the same. Now, we're going to expand that second bit. I'm going to leave the first bit because that's actually what I want it to be. It's the same as g of x, so we don't need to worry about that. The second part, though, isn't. So let's just expand that briefly. And let's just collect those numbers. So notice we've now got the first part of g of x. Then we've got minus 8 plus 10, which would be plus 2. Now that's quite irritating because we don't want that to be plus 2, we want that to be a minus 4. So we've got to figure out, well, okay, so what do we have to do to that to get it to minus 4? So instead of just f brackets x minus 2, f of x minus 2, we're going to have to take away 6 to be able to get that to be minus 4. So it would be 2 brackets x minus 2 squared plus 4x, and then it would be 2 take away 6, which would be minus 4. So that actually is the same now as g of x. So to get from f of x to g of x, we've had to subtract 2, and then we've had to subtract 2 from the input, and we've had to subtract 6 from the overall function. So whenever you do something to an overall function, it's going to affect the y-coordinates. So it's going to make it shift down 6. So we're going to go down 6 because we're subtracting 6. Whenever you do something inside the function, so that x minus 2, the minus 2 will affect the x coordinates, but it does the opposite of what you think. So a minus 2 won't go left 2, it will actually go right 2. So we're going to go right 2. And we are asked to find the transformation that moves from f of x to g of x. And you might notice that this looks very similar to a transformation which you will have done very early on in transformations, and that is translation. So it is a translation, a movement, and we can show it as a vector by vector. Now with vectors, the right goes on top, so it'd be positive 2, and the up goes at the bottom. Well, here we're going down 6, so it'd be minus 6. To find the range of this function, h of x, we need to find the minimum and maximum possible outputs. Now, because it's in a fraction, one thing we know about fractions is the larger the denominator, the smaller the overall fraction. In fact, if the denominator is a really, really big number, the fraction tends to 0. So we already know that the minimum for this function is going to be 0. And now we just need to find what the maximum will be for the range of this function. Now to do that, it's no coincidence that they've repeated the same function from earlier, and we know we can rewrite this as our answer to part A. So that's exactly what I'm going to do. So instead of 40 over that, we're going to just get our answer from part A. So it would be 2x plus 1 squared plus 8. Now to find the maximum, to find the biggest this fraction can be, we want to make the denominator the smallest it can be. Now, having rewritten it like this, you can see that if x is -1, it will just get rid of that bracket, it will just be 0. And so that will be the minimum it will be. And so it will show the overall maximum. So we're going to do 2 brackets, and then we're going to substitute in -1 there. And so it would be 40 over, it would be 0 plus 8, which would be 8. 40 divided by 8 is 5. So the biggest number it can be is 5. So the range of the function is between 0 and 5. In this question we're asked to find the equation of PA, which is this line here. Now you might notice that this line hits line L at 90 degrees, because that's one of the circle theorems, that a tangent will hit a circle at 90 degrees to the radius. So if we know the gradient of L, which we do because it's just 2, we can work out the gradient of PA, because the gradients multiply together to make -1. So the gradient of PA is going to be minus, because the gradient of L is a positive, and it would be 1 over the gradient of L, which would be 1 over 2. So it's going to be -1/2. We also know that the line will have the equation y equals mx plus c, and we know that the gradient is going to be -1/2. So we've got that bit, and we've just got to find c. And the way of doing that is we know one of the points on the line, because the line goes through the centre of the circle at 7, 5. So we're just going to substitute in those values. So 5 equals -1/2 times 7 plus c. And then we're going to just put our lines in. So we're going to start by just multiplying the right hand side. So it'll be 3.5 plus c. And we're just going to add 3.5 both sides. And so that would be 8.5 is c. So c is 8.5. And so we're just going to write this equation again, but putting in the bits that we know. So it's going to be y equals -1/2 x plus 8.5, or 8.5. Now the formula it's asked us to write is in this form here. So notice we've got 2y, so we're just going to multiply everything by 2. Let's just put my lines in to make it a bit neater. So we're going to times everything by 2. So 2y equals -x plus 17. And then we'll notice we've got the x on the left hand side, so we're just going to add x both sides. So we've got 2y plus x equals 17. So the a that we're trying to find is 17. Part B asks us to find the equation of circle C. And to do that, we need to find two things. The centre of the circle, which we are given, and the radius, which we need to find out. And when we have those two things, we can just use the equation here. All those squared, and the centre of the circle will be AB. So we can fill in parts of it now. We can fill in the fact that the x coordinate is 7 and the y coordinate is 5, but we just need to find the radius. Now to find the radius, we need to find the point P, because we've got point A. If we find out point P, we can then use Pythagoras to find out the length of the radius. So we need to find the coordinate for point P. Now to do that, it's the intersection between line L and line PA. And what we can do is we can put the two equations equal to each other and find out what x and y are at those points. So the equation for line L is this, and the equation which we've just found out for line PA is this. So what I'm going to do is just substitute in the the 2x plus 1 into the second equation. So instead of 2y, it's going to be 2 brackets 2x plus 1 plus x equals 17. And then what I'm going to do is find out what x is. So let's expand the brackets. So it'll be 4x plus 2 plus x equals 17. Add the x's. Take away 2 both sides. And then divide by 5 both sides. So x is 3. What I can then do is substitute in x equals 3 into this first equation. You could do it into either. So it's y equals 2 times 3 plus 1. So that would be 6 plus 1, which is 7. So we know that point P is going to have the coordinates 3, 7. Now we're going to use Pythagoras to find out length PA. So it is going to be the square root of the difference in the x's, which is going to be 3 minus 7 squared, plus the difference in the y's, which is going to be 7 minus 5 squared. And so when you do that, we get root 20. And so we're going to feed that in, because that's basically the radius. We're going to feed that into the equation we did earlier. So it's going to be x minus 7 squared plus y minus 5 squared. Now here the radius is squared. Well, if the radius is root 20, to square that we just get 20. And that's our answer. So part C says we've got another line that also has a gradient of 2 that also is a tangent to C, so it also touches the circle. So if I draw on the one we've got, which is line L, the only other place that can be is here, like on the other side of the circle. So what we can do is we know that to get from P to A, you go right 4, because we know from part B that the coordinates of point P is 3 for x and 7 for y. So if we put that on actually to make it a bit easier, so we know that that is 3, 7. And we know the centre of the circle is 7, 5. So we can see that we've gone right 4. We also know that we can go right another 4 to find the coordinate of this part here where the tangent hits the circle for our new line. So if we add 4 onto the centre bit, we get 11. And we're going to do the same for the y's. We know that the y for P is 7, and at the centre it's 5, so it's gone down 2. So it will go down another 2. And so 5 take away 2 is 3. So we know the coordinates will be 11, 3. So coordinates will be 11, 3 for the intersection between the tangent and the circle. And so we can just use y equals mx plus c. So y equals m, which is the gradient, but we're told that the gradient is 2, so 2x. And then it's going to be plus k, because k is the c that we're trying to find. I'm going to feed in the values for the x and the y. And let's put our lines in just to make things clearer. So y is 3, x is 11. So it's going to be 3 equals 22 plus k. So we're going to take away 22 both sides. And we're left with minus 19 equals k. So k is minus 19, and our equation will be y equals 2x minus 19. Whenever you're given these kinds of questions, always try and write down what you've got and what you can find out. So we are given vector AB, we're given vector BC, And we could work out vector AC. And we're asked to find angle BAC, which is here. So angle BAC. Now looking at that, whenever you've got three lengths of a triangle and you're asked to find the angle within the triangle, we're always going to be using cosine rule. So we know we're going to be using the cosine rule. So we've got to first of all find out what AC is. And AC will just be AB plus BC. AB is 2i plus 2j plus k. BC is I minus 8j plus 3k. And so AC is going to be 3i minus 6j plus 4k. Now the problem is that we've got those as vectors and actually we need them as lengths. So we're going to find length AB first of all. And so we've got a x component, a y component, and a z component. And whenever you need to find the length from a vector, what you do is you just use Pythagoras. Now you could use Pythagoras twice, but there's a simpler way, is just square the I, the j, and the k components. So it's going to be the 2i would be 2 squared plus 2j, so it would be 2 squared plus the k, so that would be 1 squared, and that's going to equal square root of 9 or 3. Length BC next, so we're just going to do the same thing, square each of the components. So it's an I, so it'd be 1 squared plus 8 squared. Now it should be minus 8 squared, but whenever you square something it'll always be positive, so I'm just going to ignore the signs for this, and that would be square root of 74. And finally we're going to work out AC as a length, so that will be 3 squared, and again it should be minus 6 squared, but we know it's going to be positive anyway, and that will be square root of 61. So the next part we need to write down the cosine rule, because we've got the three lengths. So cosine rule says cos of A, and it might just be helpful just to show the angles and lengths. So it's capital A for the angle that you're trying to find, lowercase a for the opposite of A, and the B and C doesn't really matter which way around you do it. So cos the angle is equal to B squared plus C squared minus A squared, and all of that over 2BC. So that's going to be square root of 9 squared plus square root of 61 squared minus square root of 74. You can see why I've left them as square roots from the previous question, because it makes this a lot easier. And then over 2 times root 9 times root 61. And so plug that into your calculator and you get minus 0.085 blah blah blah. And what we're going to do is we're going to inverse cos both sides. I'll put my lines down because we're doing stuff both sides. So inverse cos both sides. And so A is, and we're going to keep that minus 0.085 blah 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 in our calculator and just inverse cos it. So we get 94.896 blah blah blah, and to one decimal place it would be 94.9 degrees. First thing we're going to do in this question is notice that there are three roots. There's a root at 0, a root at -4, and a root at 8. And so when we're asked to find the area of R1, we know it's going to be between 0 and -4. So we need to integrate between 0 and -4, but at the moment we've got this equation as it's all factorized, and we need to expand it. So we'll start by expanding it, and I'm just going to expand the x plus 4, x minus 8. So that would be x squared minus 4x minus 32. And then I'm just going to multiply it all by x. So x cubed minus 4x squared minus 32x. So we're going to integrate it between the bounds of 0 and minus 4. And so 0 and minus 4. Just give ourselves a bit more space. So we'll worry about the bounds later, but we're just going to go through and integrate each part. So we're going to add 1 to the power, so it would be x to the power of 4, and then divide the term by 4. Add 1 to the power, so it will be 4x to the power of 3, then divide by 3. Then add 1 to the power, so it would be 32x squared, and divide by that power. And we still need to deal with the bounds. So what we're going to do is we're going to have the going to substitute in 0, and then we're going to substitute in minus 4, and we're just going to subtract them from each other. Okay, that's the simplified version. Don't write that in your exam. So when you substitute in 0, it's just going to be 0 because they're all x terms. So just it will be 0. And we're going to subtract when we substitute in minus 4. So it's going to be minus 4 to the power of 4 over 4 minus 4 times minus 4 to the power of 3 over 3 minus 32 times minus 4 squared over 2. Okay, so when you type that into the calculator, and make sure that you subtract the answer to the bit in the brackets, because you're subtracting the whole thing away from 0, or you can just work out this bit and then just negate it. You'll get 320 over 3, and that's our answer. So we're told that the area of R1 is equal to the area of R2. So this area is equal to this area. So I'm going to use that straight away. I'm going to work out what R2 is, and I'm going to get it equal to the answer I got for A. Notice it's between C and 0. So I'm just going to do the same as I did before. I'm just going to integrate between, this time, C and 0. And I'm going to just integrate the equation of the line. With respect to dx. Now it's not going to equal 320 over 3, it's going to equal minus 320 over 3 because this time it's below the line, and when it's below the line it will be negative. And we've already integrated this, so I'm just going to sort of jump straight to the end because I'm just going to substitute c into the integrated version, so it would be c to the power of 4 over 4 minus 4c cubed over 3 minus 32c squared over 2. And what I'm going to do is I'm just going to add 320 both sides. So they're all on the same side. Equal to 0. So I've substituted c into the integral, and then I've substituted 0, and I've taken the 0 away. Well, and when you substitute in the 0, you just get 0, so you're just left with the c. Okay, next we need to make these non-fractions, given the fact we're probably going to have to deal with integer coefficients for the next part. So I can times them all by 2, 3 and then 4, but if you notice 12 is in all of those, so I can just times both sides by 12, and that will give me 3c to the power of 4 minus 16c cubed minus 192c squared plus 1280. Now the next part is we need to factorize, because if you look, this has been factorized, And we're going to cheat a little bit because we're going to have a look at the answer. The answer shows us that c plus 4 is one of the factors. In fact, it's two of the factors because it's squared. So we know that there's going to be plus 4, but we have to show that. And we can show that by substituting in minus 4 using factor theorem. So we're going to substitute in minus 4. Because you can't use the fact that it's in the question as evidence that c plus 4 is one of the factors. Okay, when you type that into the calculator, you get the answer of 0. So we know that c plus 4 is a factor. Now we need to get rid of that c plus 4 from the equation. So what we're going to do is we're going to divide. Divide it out, so 3c to the power 4 minus 16c cubed minus 192c squared. There's no c term, so what we're going to do is just plus 0, then 1280. Okay, so we divide the first term by c, so we end up with 3c cubed. And we're just going to multiply that 3c cubed by the c and the plus 4. So that'll be 3c to the power of 4, and then that will be plus 12c cubed. Then we're going to add the minus 16c cubed to the plus 12c cubed. So that will be, well, we can subtract them, sorry. So that would be minus 28c cubed. Going to then do the same thing as we did before. So get this and divide it by this. So that would be minus 28c squared. And then we're going to times that by c and the 4. So that will be minus 28c cubed. And that would be minus 112c squared. And we're going to drop this down as well, so it'd be minus 192c squared, and we're going to subtract these, so that would be minus 192 plus 112, because there's two minuses, take away minus, that would give us minus 80c squared. So carry this on, divide the c out, so that would be minus 80c, and we're going to drop down the plus 0, and we're going to times the minus 80c by the c plus 4 again, so it'd be minus 80c squared, and it'd be minus 320c, and we're going to subtract those, and it would be 0 minus 320c, so that's going to be plus, so it'd be 320c. And then divide that, so that would be plus 320. Drop down the 1280, and then multiply the 320 by the c plus 4, so it would be 320c plus 1280. Now that's always a good sign when you're left with 0, because it means that c plus 4 is a factor. And this is evidence in itself that c plus 4 would be a factor. Now, looking at the question again, it's c plus 4 squared, so there's another c plus 4 there. So we're going to have to do this whole thing again, but instead of this 3c to the power 4 expression, we're going to substitute or divide it out from the 3c cubed, because effectively here we've shown that it can be written as this, so 3c cubed minus 28c squared minus 80c plus 320. So we've got to that part, but we know that it can be shown as c plus 4 squared, and it actually is evidence in itself, the fact that it divides out. We could use factor theorem again, but we can just show it by the fact that we'll end up with 0. So I'm going to just write in the expression that we found in the last section, the last part of working out. And we're going to do the same as we did before. We're going to divide the c out, so we're going to have to have 3c squared, and then times it by the c plus 4, so that would be 3c cubed plus 12c squared. Then we're going to subtract these, so that would be minus 40c squared. Going to drop down the minus 80c. Then we're going to divide the c. Whoops, forgot that bit. It's quite important. And we're going to times that by the c plus 4. So it'll be minus 40c squared, and then minus 40c times 4, which would be minus 160c. Subtract them again, and this time it will be a plus because it's minus 80 minus 160, so that's going to be positive 80c. Divide out the c, and that would be plus 80. Drop down the 320, and this is when we hold our breath that this all works out. So c times 80 is 80c, that's good. 4 times 80 is 320. So when you subtract these, we get 0. So therefore we're showing that it's going to be c plus 4 squared, and then we're left with 3c squared minus 40c plus 80. And so the values for j and k would be 3 and minus 40. Part C seems a bit confusing because surely there's only going to be one root, and I'll show you we'll show that on a diagram. And so we'll just go to a quick sketch. And we could have used the same diagram in part A, because we're just going to draw most of the same stuff. So we're going to have this, this, and then this. And so the issue we have is that the R1 and R2, so this is R1 and R2 here, the root will be basically c, right? So the value of c would be 2.450, so it would be here. It's just the value of c. But we have two answers. So where do we get the second answer from? Well, we know that when an area is under a curve, it's negative. And so because this has another section under the curve and another section above it, the point at which, and we'll call these, I don't know, R3 and R4, the point at which those two areas are the same will also give us the same area as R1. And so that part there will be at 10.883, because the areas of R3 and R4 are equal. So say the area of R3 is, I don't know, minus 20, the area of R4 would be 20, and they would just cancel out, and you're left with 0. And so R1, which is here, will equal all of this, and it will be the same thing. Or R1 will just equal this. So the question is asking us to rewrite this as this. And notice this doesn't have any logs in it, so that'll be our first thing to try and do. I can rewrite this left-hand side because of the rules of logs. Say if you take away 2 logs, you can write them as a single log as a division, so 9d over 10e. And just going to put lines in. Okay, so first thing to do is just get rid of the logs from both sides. So 9d over 10e equals d minus e. Now I want to try and get the d's together, because notice it's a single d that's equal to, and so I want to get d's on the same side. So I'm going to start by timesing both sides by 10e. That'll be 9d equals, and then 10de minus 10e squared. So I'm going to have to add the 10e squared to both sides. And I want to get the d's on the same side, so I'm going to minus the 9d both sides. we've got 10e squared equals 10de minus 9d. Now I'm going to factorise the right hand side to get d on its own. So we have a single d now, and then divide by that 10e minus 9, both sides. So we, on the left hand side, we've got 10e squared over 10e minus 9 equals d, and we can write that nicer as d equals 10e squared over 10e minus 9. And so to find a, b and c, it's just the coefficients, so a would be 10, b would be 10, and then c would be minus 9. In part B, we're asked to find the full restriction of the value of e. So if we go back to part A and have a look at our answer, you'll notice that it is a fraction, and whenever you've got a fraction, you always should be thinking about the fact that the denominator cannot be equal to 0, otherwise it will be undefined. So we're going to first of all get that so it's not equal to 0. So 10e minus 9, 10e minus 9 cannot equal 0. And we're kind of going to solve it to find out what the value of e is going to be. So add 9 both sides. So we've got 10e is not equal to 9. Then divide by 10 both sides. So e cannot equal 9/10. So e cannot equal 9/10 is a good start, but there's actually more information that we've got in the question. If we go up to the top, it says that d must be greater than e, which must be greater than 0. Now, if you have a look at this part here, you notice that the e will be squared at the top, which means that the e will always be positive for the top section. And in fact, let's just write that in, it might be a bit easier. Have it all on here. So we've got d equals 10e squared over 10e minus 9. And we're saying that this will always be positive. But the denominator, the e here, could be positive or negative. So the cutoff is 9/10. If it's any more than 9/10, that means it will be positive. So if that is greater than 9/10, it will be positive. If it's less than 9/10, it will be negative. Okay, and this shows us in the question that it cannot be negative, it has to be positive. So therefore our answer must be that e has to be greater than 9/10. We're going to start this question by just rearranging this part here. Now we've got our eye on the prize. We know that we're going to end up with h equals and then something in terms of e to the power of sine. So we've just got to bear that in mind when we start rearranging. That's kind of what we want to try and get to. So we've got dh over dt equals h cos 0.2t over 40. So what I want to do is try and get the h all on the same side, and so I want dh over h really. So we're going to times both sides by dt. So we've got dh equals, we've got h cos 0.2t over 40 dt, and then we're going to divide both sides by h. So we've got dh over h equals cos 0.2t over 40 dt. Now it's more useful probably to write that left hand side as 1 over h dh, because we can see that we can then integrate both sides with respect to dh on the left and det on the right. So we're going to integrate 1 over h with respect to h, and we're going to integrate cos 0.2t over 40 with respect to dt. Need to add some more lines. Now on the left hand side we're going to have, it's 1 over h, so it's just going to be ln h, and on the right hand side it will be 0.125 sine brackets 0.2t. If you're confused how I got that, we use the reverse chain rule with this, and the reverse chain rule just tells us that the coefficient of the t in this instance, we're going to times the coefficient of the cos. So I've basically rewritten that cos as 1 over 40 cos 0.2t, and when we integrate it, obviously cos will turn into sine and the 0.2t will stay the same, but we need to divide or times the coefficient by 1 over the coefficient of the t here. So we have 1 over 40 times 1 over 0.2, or we can divide the 1 over 40 by 0.2. When you do 1 divided by 0.2, that's just 5. So it'd be 5 over 40, or 1/8, or 0.125. Now in all these integrations we're going to have c. We're going to have c on the left and the right. We might as well just write it once, because it represents a value. Now it's important to note in the question it tells us that from the start the passenger is 6 meters above the ground. So when t equals 0, the height is going to be, so h is equal to 6. So let's write this again down here. When t equals 0, h equals 6. So we can actually use this to find out what c is, because we can just substitute this in. So ln 6 equals, now because t is 0, it's just going to cancel all of the right hand side out. Really nice. So it's going to be 0 plus c, and so therefore c is equal to ln 6. So we can write our equation again. So ln h equals 0.125 sine 0.2t, but this time we know what c is. C is ln 6. So I'm just going to extend my lines again. Now we want to try and get h on its own, because we can see that h is on its own in what we're trying to get. So it's a natural log, so we're just going to e both sides, and e is basically the opposite of ln, so that just leaves us with h. Nice. And then it just raises everything on the right hand side to e. So it's going to be 0.125 sine brackets 0.2t, and that's the first term, and then we have to do the second term, so that just gets rid of the ln, so it's just going to be, well, we're raising the whole of the right hand side to e, so it's going to be plus ln 6 here, but we can actually break that out, kind of separate it, because when you add within e, you can actually break it apart by timesing. And e ln 6 is just going to be 6, so it's times 6, or we can put the 6 at the front, so 6e 0.125 sine 0.2t. We're asked to find the maximum for our answer on part A, so we'll just have a look at the number we got. So this is the equation here that we got for the height, or the formula. Now to find the maximum we need to understand sine, and we need to figure out, well, what's the maximum sine can be. Well, as we know, sine is a wave that goes between 1 and -1, so the maximum it will be is 1. So all we need to do is find out what 6 times e to the power of 0.125 times 1 is. So we're going to work out, we're going to show the examiner what we're doing. So 6e to the power of 0.125 times 1. And when you do that on the calculator, you get 6.8023 significant figures. And let me just check what the units are. So it says in meters, so our units will be meters. So this question is quite similar to question B. We're looking basically at the sine part of question, or the answer to question A. So we're just looking at sine 0.2t, because the maximum will be when that equals 1. So we've got sine, and then that's 0.2t, and we're looking for when it equals 1. So we can just solve that, find out what t is, because that will give us the time. So we'll get inverse sine both sides, and so that's 0.2t, and that will give us pi over 2, and the next one will be 5 pi over 2. Now, the first time is this one. That's the first time it hits a maximum, and this one will be the second time. So this one here is the second time. So that's the one we're interested in. And so we're going to divide both sides by 0.2. And we've got t equals 5 pi over 2 divided by 0.2. So that's the same as times by 5. So 5 times 5 is 25, divided by 2 is 12.5 pi. And we'll check the units. I think it's in seconds, is it? Seconds. So it will be 12.5 pi seconds. I'm going to start off by rewriting this as just brackets. So when you square root a fraction, you're going to square root the top and square root the bottom. Square root's the same as to the power of a half. So this top bit is going to be 1 plus 13x to the power of a half. And the bottom bit will be the same. It will be to the power of a half, but because it's at the bottom, it will be minus a half. And we need to do the binomial expansions of this and this separately. And to do the binomial expansion, we just need to remember that it is, the first term is 1, then it's n times x, and then it's n brackets n minus 1 over 2 factorial, or just 2, x squared. We don't need any more because you can see here that we only have up until x squared. So we're going to start with this first one. Now notice, instead of x, we've got 13x. So when it says x in this formula, we're going to put 13x in there. And n is a half, so it'd be 1 plus, and this time it would be half times x, which is 13x, plus a half times a half minus 1 over 2, and then again 13x squared. Let's tidy that up, so that would be 1 plus 13 over 2x, and then it would be minus 169 over 8x squared. And the reason for that is it's 13 squared, 169, and then when you do all of this bit, it's 1 over 8, so it'll be 169 over 8. And we're going to expand the second one, so 1 minus x, which is a bit easier because we've got an x now. So it'd be 1, and then it would be minus a half times x, plus minus a half times minus a half minus 1 over 2. And it will be minus x squared. Whoops, should be a minus x here because obviously this is a minus x. So minus a half times minus x is plus a half x. And then we've got all of this stuff here. So this will get rid of the negative there, and that will be 3 over 8. So it'll be plus 3 over 8 x squared. Okay, so we've got our two brackets, and we're going to multiply them together, because obviously, as we showed at the start, our term will be, our expression is this. So we're going to grab this, and we're going to grab this, and we're going to multiply them together. So brackets 1 plus 13 over 2 x minus 169 over 8 x squared. That'll be our first bracket. And then we've got 1 plus a half x plus 3 over 8 x squared is our second bracket. Now again, looking back at the question, we only need up until x squared. So if something gives x cubed or above, we don't need to put it in, because remember, this is just an approximation. So we're going to start with this 1 here and just multiply each of the terms on the right hand side by that 1. So it'd be 1 plus a half x plus 3 over 8 x squared. And we're going to do the same with this x here. So it'd be 13 over 2 x times 1. That's nice and easy. Then 13 over 2x times a half. So that would be 13 over 4x squared. Then we're doing 13 over 2x times 3 over 8x squared. Well, that will give us x cubed, so we can ignore that one. And then the only thing we have left is this x squared and the 1 here, because everything else will give us a power more than we want. So that would be minus 169 over 8 x squared. Collect the like terms. So we've got this 1. Then we're going to add the x's. So that's the half there and the 13 over 2 there. So that would be 7x. And then the x squared. So we're going to do 3 over 8, take away 169 over 8, which would be 35 over 2 x squared. So for question B, we just need to know the rule. The rule is that if we have an expansion, such as this, and n is negative or a fraction, it's only valid when the absolute value of x, positive or negative of x, is 1 over b. So the expansion of 1 plus 13x is only valid when the absolute value of x is less than 1 over b, which is 1 over 13. So it must be less than 1 over 13. But a half is greater than 1 over 13. So is not valid. So for part C, we do a bit of magic. I always find this a bit magical, that you can put in a value of x here and it will give you an approximation to a square root. It's really clever. So I'm going to start just by substituting in the 1 over 29. So it would be 1 plus 13 times 1 over 29. I'm just going to put it in brackets just to show where we're substituting in. So it would be 1 minus 1 over 29. Or it shouldn't say equals, is approximate to 1 plus 7 times 1 over 29. Subtract 35 over 2 times 1 over 29 squared. Now we can work out the left and right hand side on the calculator, and the left hand side gives us root 6 over 2, and the right hand side gives us 2053 over 1682, and we'll put our lines in, times both sides by 2. So we've got root 6 is approximately the same as 2053 over, we can just divide the bottom by 2, 841. So in the first part of this question, we're asked to basically change that into that. So we're going to start with this. So we've got n equals a t to the power of b. And I'm going to put the lines in. Okay. So the first thing we need to do is log both sides. And the reason I've done that is because we can see that we've got log 10 in where we're trying to go. So we're going to have log base 10 n, don't need a bracket, and then we've got log base 10 of a t to the power of b. Now one of the rules of logs is that when you have a multiplication in there, we can split that up into 2 logs and that add together. So we can split that up into log 10a plus log 10 t to the power of b. One of the other rules of logs is if you've got any powers, you can bring them down into coefficients. So log 10n log 10a plus, and then we can bring that b down, so b log 10t. Now I can swap those around the other way really, so it matches it a little bit better. So it would be b log 10t plus log 10a. So looking at what we're asked to find, the m is the bit before the log 10t, so the m would be b, and the c at the end is the bit that we're just adding on, so c will be log 10a. So in order to estimate the number of microbes after 3 days, we've got to first of all find the equation for this line. Now in part A we kind of worked out the gradient and the y-intercept in terms of A and B, but here we're given an opportunity to actually work out what they really are. So the y-intercept we can see is 1.7, so the y-intercept we can see on the graph, and the gradient is going to be change in y over change in x. So the change in y is shown on here, that's 0.9. The change in x is 0.4. So it'd be 0.9 over 0.4. In your A-level you'll have to actually do this triangle yourself, but on our site we kind of do it for you. Okay, so that's going to equal 2.25. Now, we learnt on the part A that that b is m, so the gradient is b, so therefore b equals 2.25. And we also learned that log of 10a is equal to c, which we know that the y-intercept c is 1.7. And so what we're going to do is just rearrange this. So it is a equals, the base is 10, and then the power is 1.7. So a is going to be 50.118 blah blah blah. We're going to rewrite the equation of the line. So it was n equals a t to the power of b. So this isn't the equation of the line, this is kind of the original equation, although it is the equation of the line, it's the relationship. And so n equals the a, which is that 50.118 blah blah blah, times 3, because we're looking for 3 days. So 3 to the power of the b, which is our 2.25, which is our gradient. And so when you do that, you get 593.639 blah 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 on a calculator. And so to 3 significant figures, that's going to be 594 microbes. That's to 3 significant figures. So for this question, it's actually quite useful to have a look at the graph that was given to us in part B. And notice that the scale on the y-axis is log 10n. So the y-coordinate would be log 10, and then it would be 1,000,000. And that's going to equal 6. So it's going to be 6 on the y-axis. So having a look at that, our relationship, the maximum it goes up to is 4.5. So the graph only goes to 4.5 on the y-axis, and so therefore it would be extrapolated, so would be unreliable. Now, extrapolation is basically when you are estimating something with outside of the data. And a simple way of thinking about it is if you have something like age versus height, and you measure a whole load of children, it looks like there's going to be a nice linear relationship. But extrapolation is, imagine you think, okay, so when I'm age 50, I'm going to be 20 meters tall. Clearly, that's not going to work. You're not going to be 20 meters tall at the age of 50. It's because we've extrapolated. This is interpolation because, yeah, okay, it's quite reliable. There's a linear relationship there. We all know all babies are very short and all 10-year-olds are quite tall. But outside of where we found a relationship, it's very unreliable. So let's look back at our first formula. So it's n equals a t to the power of b. And what we're going to do is just put n as 1, and you'll see something that happens. So it's a times 1 to the power of b. Notice that anything, or 1 to the power of anything, is just going to be 1. So it's going to be a times 1, or just a. So this shows that when t is 1, so after 1 day, a is the number of microbes. So it's the number of microbes after 1 day. The important thing to notice straight away is it's a periodic sequence of order 3. So that will mean that A4 will equal A1 because it's just going to keep repeating. A5 will equal A2. So we're going to find A4 in terms of K, in terms of this bit here, and then we're going to work out the equation given to us. So we're going to start with A1, which equals 12. Then we're going to feed that in to the formula there to find the next term. So it says to do K times A1, which will be 12 plus 12, and all of that over the A1, which is 12. And we can cancel these. So it'd be 2k. Okay, next we're going to find A3. And I'd probably work downwards, but I'm trying to keep everything on the page just to make it a bit easier to follow. So we're going to have k, and we're going to substitute in that 2k plus 12, then all of that over 2k. And so that's going to be, we can expand the top, so it would be 2k squared plus 12k over 2k. Can divide 2 here, can divide k, so that would be k plus 6. And then we can find the fourth term, so it would be k brackets k plus 6 plus 12, all of that over k plus 6. And so we're going to end up in the brackets, it's going to be k plus 18 over k plus 6. And then we need to expand that. I'm just going to move down. So that would be k squared plus 18k over k plus 6. And I can't simplify that anymore. So we've said that A1 and equal A4, and A1 is 12. So we know that is going to equal 12. So k squared plus 18k, all of that over k plus 6, is going to equal 12. And we can show the examiner that as well, just make it really explicit that A4 will equal A1, show them what we're doing. And we can put our lines in now. And we can first of all get rid of the fraction, always get rid of the fraction. So k plus 6 times by k plus 6 both sides. And so that would be k squared plus 18k. And then it would be 12 brackets k plus 6. And then always the second step is to get rid of those brackets. So k squared plus 18k. That would be 12k plus 72. Now we want to try and get everything on the same side. So we could take away each individual term, or just take away them both at the same time. Save a bit of time. So we're going to take away the 12k and take away the 72. So we're going to have k squared. So 18k take away the 12k will be 6k. So plus 6k. And then we've got the minus 72, which equals 0. And let's just check that that's the format. Yeah. So we've got the answer of B. So B is minus 72. The best way of approaching these types of questions is just try and put k equals 6. So having a look here, we're going to have A1 as 12, A2 will be k, which we've said is 6, times that 12, plus 12, all of that over 12. 12 plus 12 is 24, and actually the 12s will all cancel, so we don't need to do that. So 2 times 6, which will be 12. So A2 is actually 12. Well, if A2 is also 12, A3 will also be 12. Because if the input is 12, it seems like the output's going to be 12. So the issue is that all of these answers are 12. And you might think, well, okay, that's fine. But the question says that it's a periodic sequence of order 3. And that is not a periodic sequence of order 3. So if k equals 6, the order is not 3. Question C is basically asking us to add the first 80 terms. Now, in order to do that, we need to find out what k is, because it's asking us to find the value. So it doesn't want it in terms of k, it wants the actual answer. So looking back at question A, we noticed that we got a nice quadratic there. And so all we need to do is solve that quadratic. So we've got k squared plus 6k minus 72. We might put some lines in. And we can factorise that. So that's going to be k plus 12 and k minus 6. So putting the left hand equal to 0. So k plus 12 equals 0. Take away 12 both sides. K equals minus 12. Right hand side equal to 0. So k minus 6 equals 0 plus 6 both sides. Will be k equals 6. Now you might be thinking, well, how do we know which one it is? Well, think back to our answer to question B, where we've explained it can't be 6. So it can't be 6, so it must be minus 12. So if our answer is minus 12, we go back to A, where we've put all of the terms in terms of k, and we actually just work out the values of them. So A1 is 12. A2 will be 2k, so that's 2 lots of minus 12, which would be minus 24. A3 is k plus 1, so it would be minus 12 plus 1, which would be minus 11. Now, there's no point of us going any further, because A4 will just be the same as A1. A5 is the same as A2, A6 the same as A3. Now, if you think about 80 terms, okay, and we're having this pattern repeat again and again and again, we're going to end up with these three things happening 26 times. So 26 lots of the pattern will bring us to 78. Now we're looking for the first 80, so we need another 2. So we need all of those added together. So it'd be the sum of those. So how do we write that? Sum of A1 plus A2 plus A3 times by 26. But we've got 2 left over, so we're going to have to add an A1 and an A2 at the end of it to get to 80. So we're going to add these together. So the sum of A1 plus A2 plus A3. I don't know why we need the sum there. It's just adding them together. It's probably better. Is going to be, well, let's add them together. So that will be minus 23. So 26 times minus 23. Then we're going to add 12 and then add minus 24. So take away 24. And when you do that, you get minus 610. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.